Alright everyone, welcome to week 5. So I guess let's get started. I guess before we do, are there any questions from last week's material or the like? Alright. Alright, so what this lesson will be on is this will be on data structures. So, specifically, structured data, what does this mean? In other words, this is just another way for us to organize the data within our application, within our program, when we're working through it. So, I guess in short, also, I love the cat in a box for this. It's very fitting. So, what are data structures? Data structures are a series of different ways. So, what's a data structure? Well, it's a way we can organize data, right? So, there's multiple different ways to do so. We're going to go through. Yes, cats are fluid indeed. Yeah, in other words, data structure is just a good way for us to organize data, store it, manage it, such as the cat in a box. Why is this important? Well, all right. So, a few different reasons. So, the biggest one that we're going to touch on here is organization and structure, right? It is far easier to represent a group of objects as an array or as a list, right, than it is to reference them each as an individual variable, just as an example. So, partially for organization. The other consideration is, and we're not going to get a huge amount into this, but some data structures have significant trade-offs and considerations with speed, some of which being significantly faster. And as we are working in Python, which is a higher level language, that performance difference is going to be even more significant. All right. So, little disclaimer here. It's really not possible for us to cover every type of data structure that is currently used in programs. There are a lot of them that are seldom used. What we're going to do is we're going to cover a couple high-level common ones. And that's pretty much it. And want to also emphasize, and this is Apple's phrasing on this one, which is very well done. There's a working solution to every problem, and there's an efficient solution to every problem. So what this means is, yes, one data structure may be able to work to store the data, to present it the way we want to in the application, but there's likely to be a more efficient solution in some cases. But of course, as always with programming, you want your application to work before you start making it efficient. Also, video doesn't exactly come across very cleanly, but am I able to... Okay, so for those who don't know, video is about the square peg in a round hole, right? Technically it'll work. Sometimes, not always. Like, this will technically, yes, it's going to fit, but it's not the intended or best solution. All right. That's a little introduction to it. So I guess let's get into a few structures. So one of the most common ones, in fact, I would argue the most common one that anyone is going to deal with here, is a list, otherwise known as an array. All right. An array, in other words, is a data structure which is going to hold a set or a series of items, right? So for example, 1, 2, 3, 4, 5, 6, 7, and 8. All right. So how exactly does a list work? So what a list is it's sequential, meaning there's a specified order on this, right? So, and also you can index it. So if we took a look down here, for example, we have print list 0. What this does is this is going to print whatever is at index 0. And yes, computers are weird. In most languages, the first element in an array or list is 0. There are a few languages where that's not the case, but the bulk of C-like languages, such as Python, in fact, bulk if not all, I think, we'll assume it starts at 0. So, for example, this will print 1, right? If this were, for example, let's say this were 2, right? Like I want to print what's at index 2. Then I'm going to go 0, 1, 2, and that's going to print 3. Same deal with list 2 on this print statement. It's going to print what's at index 3, which in this case is 0, 1, 2, 3. In this case, it would print D. Functionally, whenever we would write a for loop or whatnot, iterating over a list, this is basically what we're doing. As we're going over this list, and we're just pulling out each item one by one. So access time is referred to as fastest. The technical term on this is runtime of O of n, where n is the number of items. Index is the location where it is in the list. Starts at 0, and these are ordered. So unlike some data structures, a list does actually guarantee an order. So we've been using lists for the last couple of weeks. But that being said, actually going into detail on how they work is likely to have some questions. So are there any questions on this specific data structure? All right. Cool. And as always, if you come up with a question later, we'll loop back around and ask more questions at the end. I actually just explained this. But yeah, index 0, 1, 2, and 5 over here. So this one would be 4, and this one would be 3. All right. A list is easily expandable, and it's fast. So you can easily shorten a list. However, you can only sort it at the end. Yes, it is technically possible for you to, on paper, technically possible. It's not actually what it does under the hood, so for all intents and purposes, yes, you can quickly shorten it by removing items off the end. Removing them from the front of the list will be significantly slower. So in many cases, you would not want to do that. All right. So what's a good method here? So we've got names, right? And I apologize. Method, function, using them interchangeably on this. So we have a list of names, right? So Apple and Lucia. And we're going to append Blahai to the name, as well as Evil Witch, Raza, Ruler of Oswak. So if we want to remove the last name off of here, we would just do pop. And pop is actually a very fun function, because what this will do is not only removes it, it actually returns it. So if we had, for example, I need to get an eraser because I cannot draw apparently today. So if we had, say, a variable declaration here, like we had equals whatever, right? Then what we would end up with is we would end up having the item that was returned set to the value of that. All right. So searching within the list, relatively slow. So slow because you're going to have to check every single item and see if the item exists. And while, yes, as mentioned a little earlier, you can technically remove an item from the beginning of the list. It's very slow. But you technically can do it. It's just very, very slow. I want to say it recreates. I want to say in Python under the hood what it's doing is it's recreating the list under the hood. But I need to look into that again and verify if that's actually how it's implemented. Regardless, it takes a massive performance hit. All right. All right. So this is fun. So this is actually slicing. For those who have programmed in other languages prior, this is also frequently referred to as a substring. So what this is doing is this going to return the items between these indexes. So 0, 1, 2. So in this case, it will take everything from shield up to potion, but not broom. Reason for this being this last digit here, it's capturing up to, not including. So really, in practice, what this is going to capture indexes 2 and 3. But that is very confusing. Does anyone have any questions on that? Or anything we've covered so far on this? All right. Aha, list of lists. This is also referred to as a 2D list. And yes, this can be very hard to work with sometimes, but using it as an example. So, what is a 2D list, right? It's basically a list containing lists. Oh god, I'm having flashbacks. Yes, I know what you mean. Oh. Data structures are both really fun and extremely confusing at times. So, the list of lists, right? So, effectively the way this is working is the list is the data structure we have, right? And we're just containing another list inside of it. Which works because we can put effectively whatever we want inside of there. So, this is usually used to represent things like, for example, a board, right? Or a world, right? So let's say hypothetically, let's visualize that this is a 2D game, right? In the top and bottom corner, or I guess just in each corner, we have grass. There's some grass along the right side, and there's some grass along the left side. Along the back, we have an enemy, a little bit more grass, and in front of us we have 2 rocks. In the middle here is Apple and myself, surrounded by more grass. Now, I don't know why I'm right next to an enemy effectively, but, you know, details. So, let's say we wanted to figure out where Apple is here. So if we wanted to print Apple's exact coordinates, we would need to first reference the index of the list we are on. So under the hood, this is index 0 and 1. And then we need to, that's where we're getting 1 from. And then we need to access that element specifically. So 0, 1, 2. If it sounds like that can get extremely confusing very quickly, it's because it can. There's other data structures that one can use. Yep. I am not going to take too far of a tangent. I built a web page using this once under the hood for reasons I'm not going to get into. Don't do that. Yeah, it was a nightmare to work with. Terrifying thing is it was in the medical field, and I'm pretty sure it's still in production. Anyways. Alright. So before we go on to hash maps / dictionaries, do we have any questions on lists? I do see someone typing. Yeah. There are definitely some pretty bad examples of it. Let's pull this up real quick. So, full disclosure, I love hash maps / maps. I use them a lot in programs. So, what is a hash map? So if we go back to, for example, I think the best example I can give is if we wanted to access, say, something in a object, right? Or something in a class. Let me pull up last week's real quick because there's actually a pretty good example here on what I'm thinking of. Or the slide could just not load. That is also a possibility. All right. That's not what I'm looking for. That's the next slide. Okay, this is what I was looking for. And yes, there is a typo on this. It's fixed on the final slides, it's just not fixed in the world upload. So, um, for example, we were trying to access here, we're trying to access key X, right? Okay. If this was viewing this a little bit like a dictionary, you would have a key named X and a key named Y, right? So if I go back to lesson 5 very quickly and I just fly through this back to where we were. Okay. That's what I was looking for. Okay, now we're back. So, similar to how you would access, say, a property on an object or a member of an object, it's a similar syntax to access a key. So, under the hood. So, what do we use a hash map for? So, what a hash map is it is a set of keys. You could also view someone as members, as well as a value that is stored. There is going to be a function internally, in this case within Python, that actually is handling the logic to store this all. We're not really going to touch on that portion of the logic during this course, but for the curious, there are some examples online for it. And I think I could provide some if someone asks, if someone wants one. So, alright. So, how does a hash map differ from a list? Well, every value needs a key. And every value can also be set and accessed by a key. So, the way a hash map works is you have a key and a value, which you provide. So you would provide a key and you would provide a value. Internally, in this case, Python is going to do this for you. It runs it through a hashing function, and then it stores the value for you. Right. So, and aha, I'm not telling anyone my birthday. So, to access a key within a map is very fast. It's very efficient. Access time of n, similar to a list. The only difference being you can provide the exact value of what you need, and you're just immediately going to have it. So, adding a key value pair into a hash map is very fast and efficient. It is very fast and efficient. It's also very fast to remove it, because the way it's implemented, if we go back here real quick, because the way it's implemented, it doesn't really care what, the system doesn't really care what order any of these are in. In fact, a lot of languages, or several languages, don't actually guarantee the order of this object at all, / this data structure. So, all Python cares is they can just delete this, and the corresponding value doesn't have to reorganize it, and it continues along. Let's go through the code example. Yep. Yes, it is O of 1. My apologies, I said O of n. You are correct. Thank you for catching me on that. There's a huge distinguishment, there's a huge difference between those. Alright. So, for birthdays, we're going to create a dictionary object. I keep saying object. I apologize. It is an object under the hood. We're going to create a dictionary. And we're going to provide 2 keys, a key for Apple and a key for Lucia. And we're going to provide birthdays. So here's Apple's, and mine is a secret. So if I'm present in birthdays, what this is going to do is this is going to search the dictionary for the key, and it's going to print the value if it exists. Let's say we want to add something. Let's say for Laha. For October 13th, we can just set it right like that. There are also functions you can call to set it, but functionally they're going to do the same thing as this. And I'd argue this is a little easy to read, but, you know, choice on syntax. So, and to delete something, I don't think we've actually covered this in Python explicitly, but to delete a variable or to delete an object or to delete anything out of Python, or more specifically to instruct the Python runtime that you want to remove the data, you would call del. Other languages have a similar concept. I know JavaScript for a fact has a similar concept. But in this case, we're going to use del in order to explicitly tell Python, please drop this key from the dictionary /map. All right. So, stated a little bit earlier ago, a dictionary does not have order. It's also partially why the access time is so fast. So, it doesn't have order, so you can't really guarantee what's going to be present where. So, for example, while these may appear like they're going to be in a specific order, in practice and in application, they may not. All right. Okay. Before we go on to sets, does anyone have any questions on that? All right. So, what is a set? I'll be honest, I don't usually find myself using this a lot in applications. I mean, I do use it occasionally, but not nearly as much as some of the other ones we've covered. But a set, using computer science, it's a data structure that is guaranteed to not have any duplication, right? So, actually, I take that back. I guess I have used a set indirectly a lot. So, the way this is set up is a set is guaranteed to only have each of these items once, right? So, this means the cat, even if we attempt to add it twice, is not going to get added twice. Meanwhile, dog will very much be added. Insertion and deletion are also very quick. As for a use case for this, because I don't think we actually present a use case on that one. No, we do not present a use case on a set. So a good use case of a set, and this is actually what comes to mind for me personally, might be something, for example, a website, right? A website, you're going to have a customer ID, which is going to be an identifier for that specific customer. If you are processing that, maybe you do not want that specific customer to be showing up in your data twice, using it as an example. In fact, I would argue that if you're working with database tables, you kind of are indirectly using a set if you're doing things like primary keys, but that's more of application of this. So there are a few different ones to discuss here, and we're not going to get huge into these. To name a couple of them: queue, stack, and tree. So let's see. Queue systems function off of, I'm gonna give a very high level overview on a couple of these, and if anyone wants to dig into these further, you're welcome to, or you can ask me questions, or Apple will happily clarify. I am not going to get into the explanation on what a tree is, because that could take up the entire class. But a queue, the way it works, is it is first bit of data you add, it's going to be the last bit of data that's removed. So your data is in the same order that you added it to the system. A stack is the opposite. So with a stack, you would have, for example, I add an item. Okay, cool. Now I add another item, and I add another item, and I add another. If I want to start, say, accessing and removing items, I'm going to process down the stack in order from the last item that I added to the first item. That's just a high-level overview on those. I cannot delete that last little line, because I can show an example for a queue real quick. So a queue, say I add a piece of data here, I add some 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 data here. This will be the first data item that I work with. And I'll work my way back through in the order I added them. Yes, and Stack Overflow. No, we're not covering recursion. All right. So that is the last slide that I have on this. The next one is just a question slide, and then a bit on the workshop. Yes.
Question from Discord. Closer. With a hash map, what if there are two things that you put in that have the same value but different stored data? Like if there was two people named Ashla, but they had different birthdays.
It'll override it. That's not covered here at all, but it would override it because the keys need to be unique. Yeah, that is definitely not very clear on this, but in the case of Python, it would overwrite the value, which can result in some behavior you don't exactly expect or want in some cases. But like, let's say, for example, we added a second epoch. Let's say, for example, we added epoch here twice, and we did it with a different birthday. It's going to effectively overwrite this. Go for it.
Is that the reason why you can only have unique usernames? Because if someone could have the same username, it could wipe data from another person.
I mean, that's one possible reason, right? I mean, personally, like, if we were talking like a large system, right? Like, you would. Let me grab a marker. So, I guess so. There are. So you bring a very interesting point. So there are some systems, and I think Lichess actually had this issue where they were using the for the database itself, they were actually doing exactly that. They were using the user ID as the username itself whenever they were building the database. So it had to be unique or it would override it. In most applications, what is going on is yes, they're storing this value and it's what you log in with. But in most cases, they're adding a separate random number in place or ID that's being added through and they're using that. Username is more for you to keep things organized. The system doesn't usually care. But it is a very good question. Yeah, I would say if you made your database dependent on dependent on each username being unique, so you don't accidentally overwrite something, I'd say that's a mistake. But you know, I didn't design that system.
Reminds me of the XKCD comic drop. What is it? Bobby drop tables.
Yes. Well, I guess for anyone who's curious about the background on that, there was a Lichess does not allow you to change your username. That's why is limitations in how they designed the database on it. At least from what I've been informed from blogs and explanations that have been provided. I didn't build it personally, so if I am wrong, someone will correct me, I'm sure. Go for it.
Another Discord question. Using a dictionary function, are there any methods outside of the typical check using a loop to call on the value instead of the name?
What exactly do you mean by that? So do you mean by... Can you repeat the question? I apologize.
Let's see. Using a dictionary function, are there any methods outside of the typical check, which is using a loop to call on the value instead of the name? I'm trying to understand it myself.
So by name, are they? I'm assuming they're referring to key on this, if I'm understanding that correctly. So is there a way to iterate over? So is there a way to iterate over?
I think it's,
I don't have
is
a.
there a way to retrieve the values outside of just calling the name? Are there any other methods to get the values?
In Python specifically, I would have to check. What I would end up doing is I would end up going through a loop in order to dump them, but I'm not sure if there is a built-in function for Python on that, and I don't want to misinform anyone. Let me get back to you on that one. I don't believe there is, but let me check. Or I'm sure Apple will chime in the chat as well if... Yeah. All right. There are many for dictionary. Valid. All right. Olivia, is there one you're aware of? Saw your comment earlier.
Yeah, sorry, I was slightly distracted. I just overheard asking something about dictionaries, and I was like, yes, there are a lot of functions. Was there one?
Yes, there are. Yes, there
Or what was the one?
are. Don't worry about it.
Right.
All right. Are there any... Does anyone have any questions on anything we've covered so far?
Just a quick one, random.
Yeah, go for it.
So I know you were showing in one of the slides earlier, like you had like enemy grass. I think
Oh
it's
yeah, 2D list.
yeah, in the 2D list. Uh,
Yep.
can some so would this type of script be like, say, if you're in a game, so like to call, you go to tall grass and it calls another script to say enemy appears, kind of thing.
You could do something like that, yeah.
Yeah.
Yeah,
Because I know a
you
lot of
could, yeah.
games like MMOs use databases for all the
Like this one here?
enemies and all that. Yeah.
Yeah. You could store the enemy in there. I mean, you could store them as like a... You could do that, like... So I'm going to date myself on this. I've actually written that exact functionality in C++, like, probably 12 years ago.
That's not that long ago.
It feels like it. It feels like it.
Don't make me
But
old.
yeah, but what I ended up having is, at least when I did it back then, is I had, and keep in mind, I was still in high school when I wrote this, so this was probably not the best solution in the world. I'm kind of surprised I even came to this conclusion. But what I ended up doing is I visualized it as a 2D list under the hood. Those are terrible lines. And I took, knowing that there was going to be, say, 50 characters for the line, and I just ran them all together in a string, and then brought the string back down to a 2D list. That is not efficient at all, but if anyone's wondering how I did it back then, or how I stored the data in a world file, that's what I did. I don't recommend that. There are way better ways to do that nowadays. In fact, I think there's off-the-shelf tools that'll do it now.
Yeah.
But give me a little credit. I was 16. Anyways.
Oh, I definitely feel old.
All right, let me erase this real quick. But yeah, that is a very good question. Why can't I get rid of this one dot? There we go. Cool, cool. All right. All right. So I guess a little touch point on what we're going to do for the workshop. We're actually going to be implementing some of these. So specifically, the data structure we were planning to implement was actually going to be... There's a few we were looking to implement, but this was the one that we knew for a fact we were going to do. So, going to be extending the game/project we've been working on to incorporate some data structures like this. For the curious, and to give a small spoiler for the week after this one, there's going to be a class on specifically software design and application design. So on how you would design something in a way that it is readable and easy for you to work with. Obviously not going to be completely thorough, but that's next week. So if anyone's wondering, where do I use all these? How do I know which one? Trust me, we will get into that. My cat just decided to step under my feet. Quick tip for anyone using dictionaries: make a basic model of how your dictionary will be organized. Yep, always very good advice. Use a dictionary and a dictionary and a dictionary. Honestly, that's not the worst thing I've heard over the years. Fair. I guess what I'm saying is I've done, personally, myself, have done equal. So part of this is the fun thing with this industry, right, or with this space, is you learn a lot of when to use these things by using them incorrectly the first time. Error is definitely a far better teacher than success at times. So, like, the reason I can guarantee you I never create a function that is 300 lines is because I've done it before and I couldn't read the code afterwards. Best advice I can give is learn from it and make the most of it. Be a better programmer as a result. Alright. So, do we have any questions at all? Any from Discord? Any from Twitch?
No further questions online.
Alright. Well, I guess in that case we're gonna wrap it up a bit early. If anyone has questions about any of this, by all means, ping me or Apple, and we'll be happy to clarify. Alright. Have a good one, everyone. See you on... I'll see you later this week.
Round of applause for... Thank you!